What types of glass do manufacturers offer us today? And what are the quality requirements for different types of glass, from domestic double-glazed windows to special-purpose glass? How are they tested and what are they capable of? We've arrived in Klin, the largest glass factory in the country. They make everything here, from ordinary household mirrors to high-temperature and even antibacterial glass. 6,000 square meters of glass passes through this production facility every day, and each batch of products undergoes rigorous testing in the testing laboratory. We'll start off with a standard test. It's called a soft body impact test. We'll drop a 45-kilogram bag filled with lead pellets on the glass from several meters above. This imitates a collision with a human body.
The glass is multi-layered.
Yeah?
Double fours here, that's two 4mm thick sheets.
Yeah?
And between them there are two layers of 0.38mm thick film.
Yeah. And where is such glass used?
Well, you can use it basically anywhere. It won't be sturdy enough for a bank, but if you worry about your loved ones, for instance, you can put such glass into a double-glazed window unit in your house.
Well, let's see if this glass withstands this standard impact. What if it were ordinary glass?
Well, firstly, it would have shattered, and secondly, the shards could have injured us. Therefore, I think that, as they say, it speaks for itself.
And if I were a perpetrator trying to smash it on purpose, can I try and give this glass a hit right now?
Of course.
Yeah, it holds up all right.
Well, satisfied.
Well, yeah, I wouldn't try to repeat that with my bare hands. Now we'll subject the same glass to a hard body impact test. A 4-kilogram ball will function as that of a body, which will be dropped onto the glass from the height of 9 meters.
According to industry standards, we must drop one ball, remove it, drop another ball, remove it, drop the third one, and remove it.
If we have a through hole, then the glass
Yes.
didn't pass the test.
Yes. If the ball got through, even if it's point to point, then the test is failed. Yes, and if the ball didn't go through, it passed our test.
So, the first ball was dropped and didn't break the glass. Let's try the second one. The same. The top layer is smashed into pieces. It is clear that the layer underneath is also shattered, but the film is holding up and the ball hasn't gone through the glass. So, the testing is running as usual so far.
It is for the moment.
Okay, now we'll drop the third final ball. Go!
Well, see, the glass still withholds the impact.
And if I get on it?
Let's try.
So the only thing holding us now is the film, right?
The film is holding us, yes.
Yeah, you won't be able to break this glass with your hands or feet. But what is the breaking point of a silicate household triplex glass? I think I can break, although if I equip myself with something a little heavier. Alexander Ivanovich, would an axe do the trick?
That's a great axe. That's it. There you go. It's broken through. Yes, Alexander, great job.
Well, it's not as easy as it sounds. And to tell you what, if someone tried to break into my house with an axe like that, I would have time to run to the gun case and get the shotgun. I can put my hand through it, but in order to climb up through the glass, I would have to keep chopping for a while. In addition to triplex glass, single-layer tempered glass is also used in architecture. It's very durable, and in fact, you can't cut yourself with it.
The thing is, the tempered glass doesn't shatter into large fragments. While it can be used for glazing and fencing at stadiums, in places where there is a lot of workload as a part of a triplex glass unit. Firstly, it looks beautiful enough, and secondly, it's very reliable. Even if the glass cracks, there will be no shards, nothing. Well, it really takes a lot of effort to break such glass.
So if I stand in the middle of the glass sheet, it will hold me.
Yes, it should.
Let's try.
Sure.
And I weigh 115 kilos. So if it had been ordinary glass, it would have shattered a long time ago, right?
That's right.
It's amazing, Alexander Ivanovich. But if tempered glass is so durable, why isn't it universally used for all windows?
Well, it has technological limitations too, because you can always cut the rough glass and form it as needed, and when it comes to tempered glass, you carve it out, temper, and then you won't be able to cut or shape it anymore.
Architectural glass is not only exposed to mechanical impacts at this facility, some of them even undergo a fire test. This is fireproof glass used in facades and internal partitions of various buildings.
Normally, these types of glass are used as filling material in fire barriers. There are many varieties of them. There are fire barriers on the facades that prevent the fire from spreading from one floor to another. And there are internal fire barriers used to create emergency exit routes. The thickness of such glass varies. The thicker the glass, the higher its fire resistance class is. The more layers it has. The fire resistance of the glass we have here ranges from over 15 up to 120 minutes.
Now we're going to test not just fire resistance, but fireproof glass. It can not only resist open fire, but also doesn't let the heat pass through for a prolonged period of time. Light it up. Regular window panes shatter when heated, giving fire the access to fresh air. Fireproof glass doesn't crack, and oxygen gradually burns out in the enclosed space, which means that the fire either spreads slowly or even gradually extinguishes itself.
This is due to the fact that the polymer located between the glass sheets is completely transparent in its normal state. But when heated above 120 degrees, it foams and forms this hard, porous, opaque screen, kind of like a pumice, something like that. And because of that, it doesn't transfer excessive heat from the fire.
We conducted tests that are much more stringent than those routinely conducted by investigators during the testing of such windows. Outside, there was a naked flame, its temperature over 1,000 degrees. And now I can easily stand here touching this glass. And so, in case of a real big fire, people protected by this glass would have a high chance of survival. Laminated glass is most extensively used in transport. Safety requirement demands all car windshields be made from triplex safety glass. If they shatter, no sharp fragments are formed. The higher the speed of a transportation vehicle, the more stringent the requirements imposed on its windows are, and the more stringent the glass testing will be. Factory bench testing is all fine and good, but we like to run tests at the limit. I have already shattered architectural glass with the help of an axe. And now I'm going to try to break this experimental aircraft glass, made using the most up-to-date technology, with this hammer. There are no standards for such workloads. I can only imagine the aircraft technicians reaching for their cardiac medications. A sharp mechanical blow warms up optical polycarbonate at the impact point, at which point it becomes viscous, but hardens back just as quickly. My punches leave barely noticeable scratches on the glass. Such super strong and lightweight glass is primarily used in military aviation. In civilian industries, multi-layer mineral glass remains the undisputed favorite at the moment. Regular silicate glass is being prefabricated into triplex glass in this autoclave. A film that is between the two glass sheets melts under high pressure and temperature and tightly glues the glass sheets together. As a result, the durability of such three-layer glass exceeds the manifold that of single-layer glass. Now let's go to the testing laboratory and find out what transport glass is capable of. This unit can accelerate projectiles to 807 kilometers per hour. Such speeds are required for testing space and aviation equipment. We won't need such speeds for the next test. We're going to start off by testing the glass of the cabin of a railway engine. And we aren't going to shoot a chicken at it. We'll use something a little harder. What are you going to launch at it and at what speed?
A wine bottle with a 0.7 liter capacity. The doubled speed of the engine is 240 kilometers per hour. 120 kilometers per hour is the speed of the railway engine itself, and the additional 120 kilometers per hour is the speed of a passing train from which the bottle can fly out.
So I take it that this test was not pulled from a hat, was it?
That's right. These industry codes, developed by the Federal Agency for Railway Transport, covered a case that took place on one of the southern railways back in the 90s, where a bottle that was thrown out of the window of a passing train led to a tragic event, the death of another engine driver after it hit the windshield of the engine cabin.
So the main goal of this glass is not to shatter, or what?
It's not to allow a reach-through breakdown.
Got it. Well, let's try and shoot at it.
All right.
Well, we didn't manage to break through the glass after all.
That's right. The test result is positive. There is no reach-through breakdown. The impact speed was 249 kilometers per hour.
There was even a slight overspeed.
But it's acceptable. The glass is completely smashed. Visibility is not preserved. But in any case, the engine driver will make it to the nearest station.
Is there any kind of glass that can easily withstand similar tests?
There is, but it's not really glass, but an organic composition. In this case, you can use polycarbonate of the same thickness as this glazing product here.
Now we will put a piece of organic glass, identical to the one I could not break with a hammer, to a similar test. In the future, such glass will be installed not only on aircraft, but also on the newest trains that can accelerate to a speed of hundreds of kilometers per hour. Again, we'll shoot a wine bottle at it, but the speed of the projectile is now going to exceed 300 kilometers per hour. So, let's see what we've got here. So it's just that that's a scratch.
It left a visible mark. The moment the bottle hit the glass, the bottle itself practically turned to dust. It left no traces.
So it turns out that this kind of organic glass is more durable than silicate glass.
That's right. Of course.
Okay, and what is the threshold strength of such glass?
Well, that would bring us into the field of investigation testing, where we would conduct tests on the material itself. Glass is not actually tested with a speed like that, but let's try to shoot at it with a metal blank this time.
Have you already conducted such tests?
Here with you is going to be our first.
So that means we have a premiere today. This time we are shooting 1 kilogram heavy aluminum blank at the polycarbonate from an air gun. Its speed will exceed 500 kilometers per hour. And here's the result. The polycarbonate has finally been defeated. That was a massive blow. Well, it is clear that if we're talking about trains, such a workload and speed would simply be impossible for us to achieve.
I'd like to draw your attention to another thing. If we were to test actual rolling equipment glass, high-speed trains most likely have a very small inclination angle of glazing.
Yeah.
And we've conducted tests at the right angle.
But if we're talking about small arms, right? Or planes and helicopters, artillery armament, just how durable should the glass be to withstand an impact of a missile or bullet?
The only thing I can say here is that we are now talking about the class of bulletproof glass.
So it was not bulletproof glass?
No.
Well, then we're off to the lab where the bulletproof glass is tested. This laboratory is used to test all sorts of things, from various metals and alloys to composites, ceramics, and of course, bulletproof glass. These tests are carried out on both fragments of these materials and assembled products.
This is a semi-finished RST helmet, the likes of which are phased in by the Ministry of Internal Affairs and are actually supplied to the Ministry of Internal Affairs and the National Guard. I call it semi-finished because it's not been painted yet, but it specifically shows what it's made of. That's titanium.
Titanium, I thought so.
Yes, this is a second-class helmet. It amply withstands the impact of TT gun bullets and the lead CP1 gun bullets. The shield, along with the glass, can withstand a Makarov gun or an APS gun bullet impact.
Shall we see how you test these designs now? I'm gathering it all happens here, in this unit, right?
Yes, we're going to put the helmet, along with the head model, into the testing chamber and take a shot.
We're firing a Stechkin automated pistol at the glass of the helmet from a 5-meter distance. At the moment of impact with the glass, the bullet has the speed of 340 meters per second. So, let's see what we got. Well, we got heavy damage on the outside.
The outer glass cracked.
And on the backside, we can see a bulge, a little bump, which appeared on the inner surface of the glass.
Yeah.
And there is no penetration. That means the bullet... Where's the bullet, by the way?
The bullet bounced off and stayed in the chamber.
So the helmet has fulfilled its task.
Yes.
You know, I want to put it on and see what a soldier sees after he catches a bullet in his visor. So, well, the visibility on the right side is hindered. Sergei Bogdanovich, what pressure are you going to apply now? But are there helmet visors that can withstand submachine gun fire?
No, unfortunately not. There are barely any helmets that would withstand submachine gun fire shots at all.
I think there are no spines strong enough to withstand that.
The main problem here is the strength of a human neck itself, and equipment protection uses other types of glass.
The main difference of bulletproof glass for military equipment is the increased layering, and such glass has significantly more layers than ordinary non-armored.
This is an armored car glass of the 3rd resistance class. It withstands soft submachine gun cartridge shots, as well as all kinds of hunting weapons fire.
We've counted 5 layers of different types of glass in this sample. There are regular types of glass, but there are tempered ones too, and those that have undergone special chemical treatment to make them extra durable. So first, let's try to conduct standard tests.
The glass must withstand 3 hits on the corners of an equilateral triangle of this size. After each hit, the glass around the impact site cracks, hindering its protective properties in that area. It won't be able to crush or slow down a bullet slug anymore.
A bullet fired from a Kalashnikov assault rifle from a 5-meter distance will hit the glass at a speed of more than 700 meters per second. Will it withstand 3 hits? So, well, we can clearly see 3 hits just about on the corners of the triangle. As you said, the outer layer of glass actually shattered. Let's see what's inside. So, well, it's clear that the inner layer of the glass is smashed. But apparently this film, yes, it held it from falling in completely.
Of course, the screen is clean. The foil screen.
Ivan, but can we still try? I know that we will go far beyond certification testing limits, but can we still try and shoot it again right here?
Sure, let's try it.
Okay. The glass held up. We're going to take a third shot at the same point from the same distance. Well, Ivan, let's see what we got this time. We did manage to break it. 3 shots were fired at various points according to industry standards. We shot 2 more at the top and finally broke it through. But I take it that the probability of 3 bullets hitting the same spot as that in real-life conditions is practically non-existent.
It's very small, and the glass turned out to be much more durable than we expected.
Today, like hundreds of years ago, glass allows us to observe the outside world through it. And despite all its fragility, modern-day glass can protect us against the threats of the modern world. And we've assured ourselves of it.